Hello, and thank you for visiting RES-LLC.com, home of Reliability Engineering Solutions and Quickcheck loose fastener indicators. So let's talk about fasteners. Odds are that you use them. Odds are that they fail you. Odds are that costs you money. And odds are that makes you mad. You want to talk about it? Fastener failures. It's been estimated that approximately 70% of all mechanical failures occur due to fastener failure. That's 70% of all mechanical failures. Fastener failure could be self-loosening, tensile overload, shear overload, chemical attack, or fatigue. So what exactly is a fastener? Well, a threaded fastener is simply a long inclined plane that's curled around a central axis. The threaded fastener is used to secure two things to each other. The fastener holds these things together by utilizing a clamping force, which is commonly called a preload, that's applied by the user, and it's usually measured in units of torque. The preload consists, at least in part, of an axial stretch within the elastic range of the threaded fastener material. The preload can be thought of as a stored spring-like force that is constantly trying to push the nut back up the inclined plane, which would result in a loosening of the joint. Throw in some extra vibration, unusual stresses, or maybe just inadequate torquing, and all those add to the potential for the joint to loosen. Friction in various forms is the only force keeping the fastener in check. There's a variety of sources of friction that are utilized to resist the self-loosening. This friction attempts to lock the fastener in position. Let's take a look. Some typical methods of locking. As we said, just plain friction is one method. There's also nylon type nuts, there's locking compounds, a variety of form of locking washers, and tie wires. And these methods work perfectly every single time. Except back in the real world, where 70% of mechanical failures are due to fasteners. So how should fasteners be addressed? Well, there's a few different schools of thought. One, they could be ignored. Of course, doing that results typically in missing hardware, and that's discovered by the discovery of random hardware or of missing hardware. And that usually leads shortly to failures. Mechanical failure, leaks, maybe some excess vibration, or some other form of failure. Another method would be a preventative maintenance. You could place a preventative maintenance task in your CMMS system to do periodic retorquing, or maybe just put some preventative maintenance in place to do visual inspections. Well, I think we can all agree that ignoring the fasteners is probably not our best option. So let's take a look at preventative maintenance. A PM is basically just a time-based check to ensure the tightness of fasteners, and this will typically lead to the discovery of loose fasteners. That will typically allow the fastener to be tightened before the fastener loosens completely, but you have to think of a few things. What about cost? Cost of craftsman time to complete the task, and cost of shutting down the equipment, in some cases, to retorque. What about time? These days, your craftsman time is more valuable than ever. They have got to be focused on value-added tasks. No one can afford to just throw their time away. And then you look at the fastener itself. Added stress on the fastener. Every time a properly torqued fastener is retorqued, additional stresses are placed on that bolt. The added stress brings the bolt closer to its elastic limit and thus closer to failure. And how about the nut? No one ever thinks of the nut. Well, the nuts are slightly deformed as well as that proper clamping force is reached. Increased deformation brings the nut even closer to failure. And how about futility? Let's be honest. A retorquing task will never come at the right time. Either a properly torqued fastener will be retorqued, and with that you can see above to the stress on the fastener, or that fastener has been loose for some time and has potentially done some damage already. So preventative maintenance, not as bad as ignoring the fastener, but maybe not our best option. That leaves us with visual inspections. Well, there's some current methods of visually inspecting fasteners. They have match marking gels or paste. The paint marker is one that's commonly used, or scribe marking is also commonly used. And these methods do work fairly well as long as you can get close enough to them to inspect them. But what happens if it's a long distance away or not easily accessible, or it's behind a guard? So visual inspections, well, the current methods are okay, but they are limited. So the question is, what to do? Well, enter a better way. Quickcheck loose fastener indicators are a better way. Quickcheck is a visual system. Whether you're trying to implement Total Productive Maintenance, or TPM, the Toyota Production System, or TPS, or you're running a Kaizen event of some nature, or you just want to make quicker, safer inspections, Quickcheck is right for your facility, for your business, or whatever you're using them for. Quickcheck is, as I said, a visual system, meaning that it can be easily seen and any discrepancy is easily and quickly recognized. Faster recognition results in a quicker resolution, which will eliminate failures, leaks, or other types of failures due to loose fasteners. In addition, this visual system can eliminate potentially damaging retorquing PMs, which results in greater equipment reliability and manpower cost savings. Finally, Quickcheck can not only be used to indicate if a fastener is loose, but in today's hectic world full of interruptions, by placing an indicator on a fastener as it's torqued to its final value, it can be used as a mechanism to track which fasteners have reached their desired value. So where can you use Quickcheck? Well, the uses are pretty limited. Only things like explosion-proof electrical panels, setting aligning pump sets, instrument blanks, piping flanges, manheads, conveyors, structural members, mechanical seal retainers, aligning equipment, coal mine roof bolts, jack bolts and aligning screws, mobile equipment, or as a selling point of a manufactured piece of equipment. Pretty much the sky's the limit. Oh yeah, and if you need something that's a little more high temp, we've got that too, up to 290 degree F. So let's do a quick little check. Do you use fasteners? Check. Is your equipment important to you? Check. Do you use maintenance? Yeah, check. Is craftsman time important? Check. Is production important? Check. Is your bottom line important? Check. Well, if you can check these boxes, then you need Quickcheck loose fastener indicators. There's simply a better way.